Hey guys, I just thought of dropping you a quick one here where I want to simplify and solve for x, and this is just for your foundation in mathematics and just to check if ever you are having proper or solid foundation when it comes to logarithms as well as exponents. So what I chose here was a simple question that I took from one of the previous papers, and it is a question that deals with logs. As you can see, it says simplify, that is one part, and the second question deals with exponents, and then in this case you have to solve for x, so it's exponential equations. Now let us start with this one that deals with logs, where it says we need to simplify. So let's focus on this question. So what I'm given here is I've got this log in base 3 into log in base 2 of 8 to the exponent -1. So it's kind of a mixture of things here, but you need just to be sensitive how you approach it. So the first thing that you need to do, you have to deal with this part here. That's the first part, the brackets. Remember, BOMTAS, you have to follow or focus on the brackets. That's the first part. The second part, you have to deal with that log, and the third part, you have to deal with that exponent. So if actually it's the other way around, I think this will be the second part because it's exponent. BOMTAS, it says we have to deal with exponents first, and then the other one, which is the last one, I think it's going to be that. Now let's see how this thing unfolds. Let's start with what is inside the bracket. So if I'm given here log in base 3, now what you need to remind yourself is what is 8 in terms of 2, and if you check with a calculator you see that 8 is same as 2 to the power of 3. So what you have to do is to say 2 exponent 3, it gives you 8. Why am I choosing 2? So that I can match the bases. So the aim there is to match the bases. So I will have inside the brackets, it's log base 2 of 2 to the exponent 3. That is raised all of it to the exponent -1. So I'm just going to be applying a few laws here. At this stage, I'm given this part. Now we have a law. I'll be using the arrows, and then there is a law, the law which says if you are given log in base a of b to the power m is equal to this particular m, you are allowed to drop it down there so that it becomes m log in base a of b. So you see that you have managed to get rid of b to the exponent m. Similarly, when we are having this particular 3 first of all, we are allowed to drop it just before this log. Remember, you are working on what is inside the brackets at the moment. So what you have then will be log in base 3. Now you drop the 3 bracket, it becomes 3 log in base 2 of 2. Everything is raised, inside the brackets to the power of -1. So you see how I applied that law. That is not done again. We have a law. So here we're just applying laws. We have a law which says if you are given log in base a of a, so you see the base and the number, they are matching, it's a of a, this becomes a 1. So there is a law that says that. You can quickly test that with your calculator. For example, if you just say log in base 16 of the number must also be 16, it will just give you a 1. So that is a law. Now what you see, if you can check, we have got 2 and 2. The base is 2, the number is 2. So which means this becomes a 1. So how do you write that? You say equal to log base 3. Now we continue with our bracket is 3. Now we have log 2 of 2, which also became, remember, it became a 1. So it's up to you how you want to do it. The 3 and log, there is a multiplication sign there. So you can actually say 3 times 1 to the power -1. So this further continues. If you are simplifying now to say 3 times 1 is 3. So it's log in base 3 of 3 to the power. You can drop the bracket now. It's okay to do that to say -1. But this is now the same as saying 3 to the exponent -1. Again, we are going to repeat the laws I'm gonna use blue now. Remember, we said when there is a power, you are allowed to drop it down, just like we did with the first part here. Remember that? So that's what I'm doing now in there. So what I'm doing is I'm dropping -1 log base 3 of 3. So you see the repetition of the law. Again, if you notice, I'm having a 3 and a 3. So the base is 3, the number of 3. I'm now back again to the second part of the law that I used, which means this then becomes equal to -1 times 1, and the answer is -1. So you have got your answer there to be -1. But you know what you need to do? You need to verify your answer. You take your calculator just to verify if ever you did everything properly. So you go to the, let me just erase, take it back to the original here, and with the calculator I want to see whether this will give us a -1 whenever we are simplifying it in a way. So we just want to check if it will give us a -1. So what you do is you then verify that with the calculator, and just a moment there, if I can take my calculator, I'm having log, I need the one with the base, log in base 3, and then I've got a bracket. So you see the calculator opens a bracket, so I have to have another log, which is base 2, also in bracket it put an 8, and then outside the bracket there is a power -1. Am I right? So look at that. That is what I'm given there. If I say equal to, and then you will see that it's giving me an answer. Actually, the answer that is giving me here, it is a positive 1. So I need to just check if ever there is an error that I made. But let's check again. We're saying I'm given log. Okay, let's just verify to see if ever there's an error. Log base 3, and then into, and then I've got log base 2 of 8, close the bracket, to the power of -1 equal to, it gave me a 1. So let me check if ever there is a part that I made an error in simplifying, so that I can see where I might have lost that part. Alright, so let's look at this one here to say we had initially, remember, we had log base 3 and then log 2 of 2 to the power of 3, because that was 8. We dropped that, which is correct. That is 3 times 1. And we had log 3 to the power -1, which is same as 1 over 3. And then 3 to the power -1, we drop that to be -1 log 3. Okay, let me just use the calculator in a different way. Maybe the way sometimes the way you enter with the calculator, it can be an error. So let's do this. Let me say log base 2 of 8, just to see what it will give me. So if I say log base 2 of 8, it gives me, in this case, 3, which is what I got. I got 3 times 1. So now if I say 3, which is bracket 3 to the power -1 equal to, I'm getting 1 over 3. So with that 1 over 3, I'm going to say log base 3 of my answer, which was 1 over 3, just to see what it gives me. It gives me a -1. You see now, it actually gives me a -1. So sometimes the way the calculator can be used, it can actually look as if the answer was wrong, but it was correct. Now let us look at this other one. In this one, we are solving for x. So it's another important question, and you are supposed to solve for x in this scenario. So how do you go about solving for x here? You're given a to the exponent x is called 1 over 4 times square root of 2. The first thing is to deal with that square root of 2. Now a few notes. Remember, square root is the same as bracket power 1 over 2. So if you are given cube root, it is the same as bracket power 1 over 3, because the cube means 1 over 3. The 2 there is because there is this hidden 2 as square. If I'm given n to the power, nth root, it means you put a bracket and say power 1 over n. If that is the case, it means if I'm given square root of 2, which is, remember there is a hidden 2 there, it means bracket power, it's 2 to the power 1 over 2. Are you seeing that? So that is what we are actually given in that. So which means, using that same concept, I can move on here to say this will become 8 to the exponent x is equal to 1 over 4 dot, which is same as times 2 to the power 1 over 2. You can put a bracket, you can leave a bracket, it will still be the same thing. Then the next thing is to convert this 4. Remember 4 is equal to 2 squared. So it will then become 8 to the exponent x is equal to 1 over 2 to the power of 2 times 2 to the power of 1 over 2. My aim is to try as much as possible to make everything in terms of 2. Now you're going to ask to say, but why are you not changing 8? Which is a good question. I need to also change that 8. Remember, what is 8? 8 is equal to 2 to the power of 3. So I can also change here where there is 8 and say 2 to the power of 3, but there is an x. So you put a bracket and you put that x outside like that. It's not going to complicate things. It will actually simplify easy. So now we have expressed everything in terms of 2. Now we have to apply a few laws there so that we can simplify. The first law is when you're given 2 to the exponent, for example, a bracket, and then you've got b there, outside is same as 2 to the exponent ab, or a times b. So it's 8, that's what you do. So here, what we're going to do, we're saying 3x, meaning 3 times x. So we are going to have as 2 to the exponent 3x, or 3 times x, which is equal to, that's the first, that was one rule there. The other rule has to do with that. It's at the bottom. So the rule says if you are given 1 over a to the exponent m, you see the fraction at the bottom, we've got a power m. So what you do is you take it to the top. When it goes to the top, you introduce a negative sign. So it becomes now a to the power negative m. Meaning this 1 over 2 squared, it will be 2 to the power negative 2 dot 2 to the power 1 over 2. So you see how I was trying to, in a way, use the laws and the rules so that I don't make errors. So the rules will always guide you. We are continuing. There is a rule which says if you are given, in this case, a to the power of m times a to the power of n equal to, what you need to do, look at the bases. If the bases are the same and there is a multiplication sign between the bases, you take the base a and then you add the exponents, which is m plus n. So that rule says if you've got the same base in exponents and they are multiplying, you add. That's what we're having. We have the same base. We have a multiplication, which is a times there, means multiplication. It means we have to add the bases. So what we have now is 2 to the power of 3x is equal to 2 to the power negative 2 plus 1 over 2. Are you with me? Then we continue. 2 to the power of 3x. So we have to simplify this addition that we're having in this case. You need to simplify that. So if we're going to simplify minus 2 plus, it's minus 2 plus 1 over 2. If you do that, I'm getting minus, see that, minus 3 over 2. So if I added that, it became 2 to the power minus 3 over 2. When I've done that, I'm almost done. It's almost there. The last rule of exponents there involves equation. It says if you are given a to the power of m is equal to a to the power of n. Now look at this now. It's an equation. The bases are the same. It means when the bases are the same, you equate the exponents, meaning therefore m is also equal to n. Please don't cancel like that, because what you're trying to say is the exponent is going to fall down. If it falls down, it might break its neck. So don't cancel because the exponent is too high up there. So some students think that you are cancelling the a. You are not cancelling the a. The concept is, if the bases are the same, you equate the exponent. So these two you equate if these two are the same. Are you with me? Similarly, we are here. The bases are the same. This is our exponent. This is our exponent. It means you equate that. So what I'm having at this stage is 3 to the exponent x is equal to minus 3 over 2. Are you seeing that? Now it's up to you how you want to solve the equation, but the simplest thing, remember, you're looking for x, you divide by 3 on both sides. Divide by 3 on both sides. It's very important to notice how you're going to enter that in your calculator. If you divide by 3, therefore you are going to have x is equal to, as I say, it's very important how you enter that in the calculator. Look at this. When you're entering in the calculator, you have a fraction, but on top there is a cursor. You must put another fraction, first a negative, and then with the negative there is another fraction on top. Then you've got your 3 over 2. Are you seeing how it's like? Then we are dividing that, dividing it by 3, and then the answer is minus a half, so it is negative 1 over 2. Alternatively, when you are at this stage to say 3x, okay, let me use just a different marker. If you're at this stage to say 3x is equal to minus 3 over 2 and you don't want to rely on the calculator, what you can do, remove that fraction there, you multiply by 3, by 2. So you multiply by 2. What you do on the left, you do on the right. Now 3 times 2, which is 6x, is equal to, so you get rid of that fraction, which is minus 3. Then you divide. Now see, it's flat, no fraction. Then you can simply divide by 6, such that now what you're having is x is equal to now minus 3 over 6, 3 into 3, 1, 3 into 6, 2, which is negative 1 over 2. Up to you, but at the end of the day, you still get the same answer, and the approach can be different. So we got our value of x, and you can see that there is quite a lot of rules that we're using here. That's why I chose these two questions, because it was forcing you to almost use most of the rules that you find in exponents as well as logs. So now we said x was a negative half. Surely we need to test our answer. So what you do, you come in here, you put x, remember x is negative 1 over 2. You simplify the left hand side, simplify the right hand side, and see what it gives us. So let's start with the left hand side. It's 8 to the exponent negative 1 over 2. And then what is it giving me? It's giving me 0,3535. So I got this side it's 0,3535. This side. Let's try the other side. I do the same thing. I find in this scenario, I find what is 1 over 2 multiplied, 1 over 4 times, which is dot there, square root of 2 equal to, and then when you say equal to, press SD. It is 0,35355. I didn't round off that one. 0,3535. So you can see that my left hand side is balancing with my right hand side. So what it means, guys, is this answer of x is equal to negative half is correct. So I know it looks, you'll be asking yourself, I just brought in a funny question, blah 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 blah, but at the end of the day, I just wanted to bring you some concepts that sometimes you take them for granted, but you might discover that these are important concepts as you are learning your mathematics in a higher grade. So we've come to the end of our lesson, guys. Remember to subscribe to our channel if you have not done so, and also to turn on that notification bell if you have not done so. Share the channel with your friends and your colleagues, and we will also gladly bring more videos that are helpful to you. Some of these questions I get them from students who send me some of these questions to say please assist with this question. So if you are having a question that you want me to tackle or a topic that you want me to look into, just feel free and leave a comment below. We have come to the end of our lesson. Thank you.